Hi class, in this video we're going to be talking about how to solve linear inequalities. So right now I have a linear inequality as a picture. So it says the left side is worth more than the right side. Okay, that's why we have this inequality here. It asks us how many yellow coins must the red one be worth to make this true. So if this red coin right here, I don't know what it's actually worth. So I'm going to write X. And I have 3 yellow coins, so I'm going to write plus 3. And I'm just going to write the greater than sign because that's my inequality that I'm told. And on the other side, I have 1, 2, 3, 4, 5, 6, 7, 8 coins. So now we just solve this as if it's an equation. If I take away 3 from both sides, like you're going to see in the picture right now, how many coins do I have left on the right side? 5, right? So all I did here was take away 3 from both sides, just like we're solving a regular one-step equation. Now I just have x is greater than 5. So that's the answer to my inequality. Instead of writing x equals to 5, I keep my inequality and just say x is greater than 5. Now let's go over another example. What does x need in order for 5x minus 1 greater than 34 to be true? So in this case here, what I'm going to do is I'm going to add 1 to both sides. I'm going to solve it as if I'm solving an equation. If I add 1 to both sides, I'm now going to have 5x is greater than 35. Now I just want x by itself, so I'm going to divide both sides by 5. And upon doing so, I'm now going to have x is greater than 35 divided by 5 is 7, so x is greater than 7. So I just solved it like I would solve a linear equation. And now I'm going to test if my answer works by substituting in a potential value. So in this case, let's try x is equal to 10. So x greater than 7, 10 is apparently greater than 7. So let's substitute that in and see if this is going to be true. So if I replace x with 10 instead of 5x, which is 5 times x, what's 5 times 10? 50, right? And what's 50 minus 1? 49. Now, is it true that 49 is greater than 34? Yes, so we can say that it worked. Now let's try subbing in a value that doesn't work. So let's try x equals to 4, because I know that 4 cannot be greater than 7. So now instead of 5 times x, I have 5 times 4 minus 1. Well, 5 times 4 is 20. 20 minus 1 is 19. Is it true that 19 is greater than 34? Absolutely not. So it does not work, meaning this equation is now verified because x needs to be larger than 7 for this inequality to work, right? That's why 10 worked here and 4 did not. Okay, now I want to go over a really important concept. So is this true? Is 5 greater than 1? Yes. What if we multiplied by a negative number? So what if I multiplied both sides by negative 3? 5 times negative 3 is negative 15. 1 times negative 3 is negative 3. Now I'm going to ask you this question. Is the left side still greater than the right side? Because before the left side here was greater than the right side. After I times it by the negative, is this true? Is negative 15 greater than negative 3? No, it's not, right? That's not true. So there's actually a hidden rule for inequalities here. Notice how I switched the signs. The rule is whenever you multiply or divide by a negative number, you have to switch the directions of the inequality. It's always true. It's the one rule that makes it different than solving equations. So again, anytime you multiply or divide by a negative number on both sides, you must switch the inequalities. Now, if you add or subtract a negative number, you don't have to switch it. But when you multiply or divide, you must switch the inequality direction. So let's go over an example like this. What value can x be for the statement to be true? So here I have this equation, x divided by negative 4 minus 10 is greater than negative 15. So my first step is to isolate for x. I'm going to use reverse BEDMAS. So I'm going to start by adding 10 to both sides. Now, if I add 10 to both sides, because I want to cancel this negative 10 here, I'm just going to get x divided by negative 4 is greater than negative 5, because negative 15 plus 10 is negative 5. Now I'm going to multiply both sides by negative 4. If I multiply both sides by negative 4, the negatives 4 cancel on this left side, so I'm just left with x. Now negative 4 times negative 5 is going to be positive 20. Now because I multiplied by a negative number, I can't write x is greater than 20 now. I have to do the reverse and switch the signs. So x is actually less than 20. Now let's check our work to see if this is true. So yeah, because we multiplied by a negative, our inequality signs switch directions. Now let's test our solution. So let's pick a value. Choose a value that is less than 20 to see if it works for x. So if I let x be equal to 0, let's see if my left side is still less than my right side. 0. Is 0 less than 20? Yes. So that works. Let's just put it back into the original and kind of see. So if I let x here within my original equation be 0, I have 0 divided by negative 4, which is 0, and 0 minus 10 is negative 10. Now, is it true that negative 10 is greater than negative 15? Yes, that is true. So it looks like my inequality does work. And on a number line, I would just find where 20 is, and I'm going to draw a empty circle because I can't be equal to 20. I only can be less than 20. And if I'm less than 20, I would go towards the left side.